and any music.
Okay, this is the matrix K1. Okay, the task is we get the K1 matrix and we have to find the inverse using the adjoint method. And after we get the inverse, we have to multiply by P and we have to determine the answer. We have to determine if we get the answer or not. Okay, so the inverse of a matrix is equal to 1 over the determinant multiplied by the adjoint. To find the adjoint of the matrix, we use the triangle method. As you can see, there is positive 1 and there is the negative 1. So the triangle method works by we multiply this line, we multiply the number of this line, and we multiply the number of this line. This is the triangle method, and thus we get the positive one. And for the negative one, it's quite the same. We multiply the number of this line, the number of this line, and the number of this line, and we get the negative one. So this is the summary. We apply the triangle method to the K1 matrix. Okay, since our matrix K1 is 4 by 4, but we want to use the triangle matrix is 3 by 3. So this matrix we have to close row 1 and we have to close column 1. Thus we get the minor. Okay, to solve this minor, we apply the triangle method and we get the answer 16. Okay, for the next one, we close the row 1 and we close the second column. Thus we get 21. So we apply the triangle method for further calculation. We get 10, we get negative 24, we get 14, we get 17, we get negative 15, we got negative 28, we got negative 14, we got 35, we got 28, we got 25, we got negative 7, we got 24, and lastly we get 27. All the answers that I mentioned just now is the cofactor of the matrix. In order to find the adjoint of the matrix, this cofactor, we have to transpose it and we get the adjoint. So after we find the adjoint, we have to find the determinant. Okay, we use the Barrett's algorithm to find the determinant. As you can see, the matrix, the first row of the matrix, we put it here, and to get this, we multiply 1 by 1 and minus 1 by 1. Remember that the first row of the matrix and the first column of the matrix is 1. We used in all of the operation. Okay, for this, we multiply 1 by 2 and we subtract 2 multiplied by 1, then we get this. Okay, for the second column, 1 multiplied by 2 and minus 1 multiplied by 5, and the operation continues until we get all the rows and column. After that, we get this 4 by 4 matrix, and as you can see, the second row 0, -3, 2 and 1. We put to this, and same calculation we use for the first one. We apply for the second step until the last step. Okay, as you can see, this is the final answer. Thus we get negative 91 for the determinant. And after that, we can use this formula to get the inverse of matrix K1. By using the formula, negative 1 over the determinant, that is 91, we multiply by the adjoint, and we get this answer. This is the inverse of K1. Then this is matrix P, and this is matrix K1. We multiply, then we get the answer.
So the conclusion is matrix K1 is not the answer because we can't describe this answer due to its fraction form.
Okay, now for the set C, matrix K2, given the matrix 3, 2, 1, 5, 1, 5, 3, 2, 4, -1, 0, 9, 9, 6, 3 and 15. So for K2 matrix, we need to solve using the ERO method. So the first step, we need to find the determinant first. So we take the first row times 1/3. Then we take the second row. So the second row minus 1/3 times the first row, and then the answer we put in the second row. Next, the first row we times by -4/3, and then we include the third row. So the third row minus 4/3 times the first row -4/3. So we can get the answer, and then we put the answer in the third row, and then we can get this matrix. Next step, we take the first row times by -3 and include the fourth row. So the fourth row minus by 3 times the first row, and then the answer we put in the fourth row. So the final answer we can get is 0. In order to solve this matrix, we need to find the inverse, but unfortunately, to find the inverse, we need to find the determinant. The determinant is 0, hence we cannot find the inverse, so this matrix is uninversible. Hence, we cannot decrypt this matrix.
For K3, we get this matrix and then we need to inverse it using the arrow technique. First step is the row 1 will multiply with 1/5, and then we get this answer. The second step is row number 2 will be minus with 3 times row 1, and then we get this result. Step number 3, row number 3 is then minus with row number 1, and then we get this. The fourth step is row number 4 is minus with 2 times row 1, and then we get this. The fifth step is row number 2 is multiply with 5, and then we get this. Sixth step, row number 3 is minus with 7/5 row 2, and then we get this answer. The next step, row number 4 is added with 1/5 row 2, and then we get this. Then row number 3, we multiply it with 1 over 3 to get this result. After that, row number 4 is minus with row number 3 to get this. Then row number 4 is multiplied with 3 over 13 to get this. After that, row number 3 is added with 4 over 3 row 4 to get this. Row number 2 then is minus with 4 times row 4, and then we get this. Next, row number 1 is minus with 2 over 5 row 4 to get this. After that, row number 2 we added with 2 row 3, and then we get this. Next step, row number 1 is minus with 4 over 5 row 3, and then we get this. Lastly, row number 1 is minus with 3 over 5 row 2, and then we get this. So we can see that we get this result, and then this is the final answer, the inverse function for this matrix. So this is the secret code that Along gave to Busu, and we multiply it with the inverse matrix that we get previously to get this whole number. The whole number, we convert it into letters, and then we will get this answer. So this is the location that Along want to meet Busu at Asasi Pertanian.
So for question B, among these three messages K1, K2 and K3, which messages do you think is correct, and explain? So the answer is, the correct message among these three matrix is K3. It is because K3 is inversible, and we multiply by P with inverse K3, we can get a 4 times 4 matrix that have a range of number from 0 to 26. Thus, we can decrypt this using coding method and get the answer Asasi Pertanian. So for question C, why do you consider the other messages are incorrect? State your reason. The reason why matrix K1 is not the correct message is because when we multiply P with inverse K1, we obtain a matrix 4x4 that contains negative and fraction form of numbers. Thus, the message cannot be decrypted using the coding method. Same goes to matrix K2. It is not the correct message because we cannot inverse the matrix, and as the determinant is 0, so the message also cannot be decrypted. Thank you.